Layered communication. Till now, I've explained data communication or data transfer between two PCs using a very simplified way. In this lesson, I will explain how data moves from upper layer to the lower layer on the transmit side and from the lower layer to the upper layer on the receive side. I will also explain how the same layer on the transmit side and receive side perform opposite functions, how they worked as buddies or peers, and finally I will also touch upon the concept of packet. We have frames on layer 2. Similarly, we have packets at layer 3. Now, layer 2 communication via Ethernet frames. Anytime we want a PC to send data to another PC, at data link layer it is done using a frame. A frame is created. It consists of DMAC, SMAC and data. These fields we have studied in quite a detail in the previous lessons. Yes, the type and checksum fields have not yet been covered, but I promise I'll be covering them pretty soon. Now once the frame is created, PC1 sends it across, PC2 receives it, checks the value of the DMAC, and if it matches its own, it accepts the frame. Now this was the simplified approach of explanation. Now let me go into the layered approach. I have PC1 and PC2 and I am now presenting the two different layers in detail. Data link layer and physical on both sides, PC1 and PC2. The physical layer on both the PCs are connected using a wire. First step, PC1 wants to send data to PC2. At data link layer, it will create a frame. I am going to draw a virtual boundary between data link layer and physical layer so that it's easy for you to visualize and understand. Now this frame is passed from the data link layer to the physical layer. That means from upper layer to the lower layer. The physical layer will then receive this and then convert the received frame into bits. Now these bits are then transmitted across the wire to the other PC. The physical layer on PC2 is acting as the receiver and hence will receive the bits, convert these bits to frame, and once the frame is created, it will pass these frame to the upper layer, data link layer, like this. And when the data link layer receives it, it will process the frame. Now let me further elaborate that in a frame structure. This was just the language. Now I'm going to demonstrate using a frame picture. At the data link layer, okay, at PC1 we have MAC address A and PC2 has MAC address B. Let's create a frame at data link layer and walk through the process. Frame created, passed down, physical layer converts into bits, transmits the bits across. Physical layer receives it, converts the bits into frame, and the frame is then passed up. Transmit side from upper layer to lower layer and then across the wire or the physical medium. On the receiving side from the physical layer to the data link layer. This is how it is. Now remember, the data link layer on both the sides are talking the same language. What is the language at data link layer? Frames. Data link layer on the transmit side is creating the frame. Data link layer on the receiving side is processing the frame. Okay, but they are not having a direct communication. The communication that is happening is via the physical layer, like this. Okay. Similarly, the physical layer on both the sides are talking with each other. What language are they talking about? They are talking in the language of bits. Physical layer on this side is transmitting bits. The physical layer on the other side is receiving the bits. Okay. So this is the layered structure where I am just presenting layer 1 and layer 2. Now let's add the concept of layer 3 also. First we will keep it simple. So let me explain the simple concept. First, the packet. Just like we had frames at the layer 2, we have packets at layer 3. Okay. So anytime a PC wants to send data to another PC at network layer, we create a packet. Okay. And the packet, let's say PC1 has an IP address this and PC2 has this. A packet consists of a destination IP address, source IP address, and data field. And this is what we'll be focusing primarily in the upcoming lessons. There are other fields also, like other parts of the header, that I'll be covering in later lectures. But first, as always I do, I'll keep the concept very simple, make you understand the majority of it, and then when the need arises to go over those details covered in those header parts or the other fields, I will definitely cover those as well. But now let's focus on this. So PC1 creates a packet and sends it across to PC2. Now PC2 receives the packet, checks the value of the destination IP. If it matches its own IP, then it will accept it. This was the simplified explanation. Now let's dive into the layered structure. We have PC1 and PC2. We have the 3 layers in both sides. PC1 is the transmitting side and PC2 is the receiving side. On PC1 at the network layer, a packet is created. This packet is then sent down across the boundary. The data link layer receives the packet and then creates a frame. How does it create a frame is going to be covered in the next lesson when I'm going to talk about encapsulation and decapsulation. So stay tuned. Now once the frame is created, the frame is passed down to the physical layer. The physical layer receives this frame and then converts the frame into bits. And once the bits are created, the bits are then transmitted across the wire. On PC2, the physical layer is receiving the bits and then converts these bits into frame. The frame is then passed from itself to the upper layer. The data link layer receives the frame and then processes the frame. And once after processing the frame, it gets the packet. It passes the packet to the upper layer, which is the network. The network layer receives the packet and then processes the packet. Now, if you notice and go into the details of what literature I have presented on both sides and the transmit and receive side, you can notice that the transmit side and the receive side, the same layer is performing opposite functions. Let's focus on physical layer first. Convert frame to bits, convert bits to frame. Receive frame from data link layer, pass frame to data link layer. Transmit bit, receive bit. So opposite functions. Let's move the focus to data link layer. Receive packet from network layer, pass packet to network layer. Create frame, process the receive frame. Pass frame to physical layer and receive frame from physical layer. So same thing. Data link layer also on the transmit side and receive side are performing opposite functions. And moving the focus to network layer, the network layer creates a packet. On the receiving side, it processes the packet. On the transmit side, network layer passes the packet to the data link layer. On the receive side, it receives the packet from the data link layer. And hence we can say that the physical layers on both sides are complementing each other and are peer layers. Data link layer on both the sides are complementing each other, performing opposite functions and therefore are peer layers. And similarly, the network layer on both the sides is performing the opposite functions and acting as peers. Okay. Network layer is operating at packets. Data link layer is operating at frames and the physical layer is operating at bits. To summarize, Remember, the data transfer takes place from upper layer to the lower layer on the transmit side and from the lower layer to the upper layer on the receiving side. Do remember the concept of peer layers. Physical layers on both the sides, for example, act as peers. And finally, do remember that on physical layer we deal with bits, at data link layer we deal with frames, and on the network layer we have the concept of packets.